Okay, so today I'd like to talk about the rules for finding the nth term in a sequence modeling linear growth or decay. So this is where we are wanting to find the rule that will help us calculate a particular term directly. So previously we've been using recursion and going through step by step by step each time. Now we're going to use a rule. Now you've got to be careful when doing questions. When it says to use recursion, you must use that recursion relation. When it says to find a rule, you can then find a rule. Don't find and apply a rule when it says for you to use a recurrence relation. Okay, so let's look at how we figure out how rules and the recurrence relations connect. So here I've got an example. You invest $5,000 at 2% per annum simple interest. So that simple interest, remember, is calculated on what you initially invested, your principal, that $5,000. So 2% of $5,000 is $100. So we'll earn $100 per year. So our recurrence relation for that is V0 equals 5,000. And so Vn plus 1 equals Vn plus 100. So let's look at a few years of this. So we start off V0, then V1 is V0 plus 100. And so because we've got that 1 year of interest, we've got that $100. So here our V2 is V1 plus 100. Or what was V1? V1 was V0 plus 100. Or in other words, V0 plus 2 times 100. So V3 is equal to V2 plus 100. And what was V2? V2 was V0 plus 2 times 100. Then we plus another 100, so that's V0 plus 3 times 100. So we can see here that we've made that rule, that pattern. So that Vn is equal to 5,000 plus n times 100. That would be our rule for finding the nth term. So we can immediately just think, well, after 12 years, our V12 will be equal to 5,000 plus 12 times 100 is 6,200. So there's the formulas you should be remembering and making sure it's in your bound reference. The Vn equal to V0 plus n times d for linear growth, or minus nd for linear decay. So growth is when the amount is growing, or decay is when it's decreasing. So for simple interest investments and loans, you can use that idea where you get that common difference by timesing your percentage rate times the V0. Or, in other words, that Vn equals to the V0 plus how many times we've done it times the rate times V0. So that's just the D written out. So our depreciation we think of as decay because the value of that asset is decreasing. And that unit cost depreciation is the same. With the flat rate depreciation, we think of it with that percentage, but the unit cost, we've decided how much it's going to go down by. Okay, so here's a worked example. Jared bought his car 5 years ago for $15,000. Its current market value. Now, market value means what he could sell it for. Okay, that's what market value means. What he could sell it for is $7,500. Assuming straight line depreciation, that's the way some people can refer to that flat rate depreciation. Find the car's annual depreciation rate. So let's think about this. Our total depreciation is equal to how much we originally paid for it, take away how much it's currently worth. So how much depreciation is that $15,000 take away $7,500. So it's ended up being that it's actually depreciated by the $7,500. So that rate of depreciation is total depreciation divided by how many years has it depreciated. So it's been 5 years. So it's depreciated at $1,500 per year, $1,500 per year. So thinking about the relationship between future value and time, find that relationship. So find the rule and use it to find when the car will have a value of $3,000. That might be the point when Jared decides that he'll get rid of it. So there's our general formula, Vn equals V0 take away N times D. Then I sub in what we know. We know V0 is 15,000. We know our D is 1,500. That's how much it goes down by per year. So here N would be standing in for the number of years. It's important that that period of time is not always years, so you need to watch what that question is saying. So we need to figure out when Vn is $3,000. So I sub in my $3,000 and I want to figure out the N. Now I can do it by hand or I can do it on my CAS, whichever you like. So the car will have a value of $3,000 after 8 years. So 8 years after the purchase, it would be worth $3,000. I might pause it here. So the next video, I'll go through some past exam papers.